Right. So we're going to look at double angle formulas. Actually, sorry, before that, we have to look at compound angle formulas, which is just in general. Let me explain something. Let me just say you have sine of mm, sine of what? I think. Come on, angle.
Alpha.
No, no, angle. Angle. Like actual angle.
Oh, oh, um, 60.
Let me say 150. Now, you're supposed to learn some chart or something of standard values. So like you're supposed to know what sine 60 is, sine 90. You know what I mean? Those values.
Yeah,
Okay, right? So we know those values. Let me just say we have an angle like sine 150. Is that in the table? Did you ever
um,
did you ever learn what sine 150 is?
sine 150.
No,
I remember.
that wasn't one of the standard angles. The standard angle is like 30, 60, 90, 45. So 150 is completely out of the question. But ain't you know what let me ask that question. Ain't you supposed to know what sine 60 is?
Yeah,
Ain't you supposed to know what sine 90 is?
yeah.
So what we could do is we could split that angle, that 150, into 60 plus 90. And that's the whole concept of the compound angle formula. Now, this is the mistake people make. They say that that is equal to sine 60 plus sine 90. Are you going to do that?
I was thinking to,
No. It have a it have a formula. Anytime you split an angle into a compound, you have to follow this formula. So sine A plus B, that's equal to sine A cos B plus cos A sine B. And if we have sine, if you let me just say you have an angle like let me see. Uh hmm thinking. All right, let me just say we have an angle like sine 15. You ever learn what sine 15 is? Mark, to that question. You ever learn what sine 15 is?
now,
No. But I want you to think in terms of the standard angle values. Are there any angles we could possibly add or subtract to get 15? Any angles that we know?
um, 45 minus 30.
And we know what sine 45 is?
Yeah,
A root 2 on 2. And sine 30. Are we supposed to know that?
yeah.
What is sine 30?
Sine 30 is,
Just a half.
yeah,
So you see, we know sine 45 and we know sine 30. But are we going to say that that is equal to sine 45 minus sine 30? Are we going to say that?
yeah.
No, we're not going to say that. We're going to follow the compound angle formula. And those are the formulas we use anytime you want to split angles. So copy that down. Sine A plus B and sine A minus B.
Yeah, I get you.
Okay, nice. Nice. Right? And this is an example you can copy down. So let me just say I had sine 150. We do not know what sine 150 is. But we do know what sine we could express 150 as 90 plus 60. And 90 and 60 are two angles that we know. Whenever you're picking two angles, it must be standard angles. You hear that? It must be standard. It must, it must be something you're supposed to know.
the table.
Yeah, from the table. Must. I have a picture of the table. Let me get it. Um, the table. So standard angle values are 0, 30, 45, 60, 90, 180, 270, 360. If you want, you can take a screenshot of this and send it on the chat.
Alright.
These are the angles you're supposed to know. Good morning, Kristen.
Send the change.
All right, nice. Okay, no problem, Kristen. Something happened with the bio exam, and you say it was good. They said that the bio exam was good. So, yeah. So when we do in compound angle formula, we're splitting an angle into either sum or difference. And we're going to pick two of the standard value angles. So let me explain the example real quick. So Nicholas, we split up the 150 into 90 plus 60. So if I'm comparing it to the formula sine A plus B, could you tell me what the A becomes? What
Is
is
90
A
and the
is
B.
right? So when I'm using the formula, instead of writing sine A, I'm going to write sine 90. Instead of writing cos 60, sorry. Instead of writing cos B, I will say cos 60. Instead of writing cos A, I would write cos 90. Think you get your point.
Yeah.
Right, and that's a general formula. That's how you use it. I see you could copy that down. Oh, oh, see, I was kind of curious just to know how you did. Ah, you do good? I think you do good. Like 80s, 90s. Wait, okay, okay. That's impressive. Big up yourself. Big up yourself.
Okay, then.
Nice. Now, this is the compound angle formula for cos. Same situation. Imagine if you had cos 150, cos 270. Same exact situation. Right? So copy this down.
Okay.
Right, so you have a copy down. Kirsten, let me know
Okay.
if you have a Kirsten, you would have missed out some stuff. We started compound angle formulas. I'm not sure. Did you get the time to copy down the compound angle formula for sine and the example? No? All right, take it down. In the meantime, Nicholas, let me give you a question. I want you to find sine, sorry, I want you to find cos of, let me think, of 210. So Nicholas, try that.
All right. I get root 3 over 2.
Wait, yeah,
Minus root 3 over 2.
that's correct. Somebody work out.
All right.
All right, Kirsten, are you finished copying down the compound angle formula for sine and the example? Okay, cool, cool. So Kirsten, just to explain, they are supposed to be angles that you know. You have a Casio, so you don't worry too much. But these are the angles you're supposed to know. You need to know 0, 30, 45, 60, 90, 180, 270, 260. Let's just say the way to find sine 150 degrees, that not in that table. But to get 150, you could say 90 plus 60 or 60 plus 90. That is the sum of two angles. Since we are combining two angles, it's compound. So we have to use one of these formulas. Since we are adding two angles, we will use the first one because you're adding two angles to get the answer. So sine A plus B. So A is 90, B is 60. So I will say sine 90 cos 60. Look at the formula, sine A cos B. A is 90, B is 60. And then I'm going to say cos A. A is 90, so cos 90 sine 60. You're supposed to know what sine 90 is. That's 1. Cos 60 is a half, right? Cos 90 is 0. and sine 60 is root 3 over 2. So the final answer is a half. Kirsten, does your calculator give you the exact answer? Like put sine 60 in your calculator. Tell me if you get root 3 over 2. Put sine 60. Okay, yeah, Nicholas, that's good. That's good. Kirsten, if you put sine 60 in a calculator, are you getting root 3 over 2? Can I hear it now? Okay, I see it. Send me a picture. Put cos 60. I'm sorry, not cos 60. It don't matter. Put cos 60 or sine 60. If you put cos 60, you're supposed to get a half. If you put sine 60, you're supposed to get root 3 over 2. Sine 60. What mode is your calculator in? By chance, did you get minus 0.952? Tell me if that's where you got question. What was the answer that you got? And I'm not supposed to get a um yeah, your calculator is definitely in radians mode. It's 9 degrees. You get, let me guess, you get minus 0.304810. Sure you get sure. You had to put your calculator in degrees. Come on, you know how to put your calculator in degrees? All right, put it in degrees and try it back. So if you want to put it in degrees mode, you're gonna press shift mode and 3. Well, at least that's on my calculator. Shift mode 3. And your calculator will be in degrees mode. So when you put sine 60, you're supposed to get root 3 over 2. If not root 3 over 2, you're supposed to get 0.886. But if that's the case, sorry, your Casio can't give you the exact answer. Um, oh shucks. Well, you gotta remember this then. You gotta remember this chart here. So if we look at sine 60, sorry, sine 60 is root 3 over 2. Yeah, you gotta remember that then. Because they want the exact answer. You cannot put the answer in decimals, eh? To do that. That's not that's I would you get the question wrong. They want the answer in the exact form. Right. Right. So Kirsten, you could copy down this in the meantime. I'm going to explain, actually pay attention to this example. Pay attention to this example, as a matter of fact. So let's just say we have cos 210. I want to figure out what cos 210 degrees would be. Now, if I look in my table, I'm not seeing 210. But, Kirsten, what two angles could I subtract or add to get 210? Are there any angles here that I could sum or minus to get 210? How could I get 210 using these angles? Salman Kirsten, which two angles could I add or subtract to get 210? Yeah, you can say 270 minus 60, right? So I'm gonna write cos 270 minus 60. So if that's the formula I'm using, would I use cos A plus B or would I use cos A minus B? Right? I would use cos A minus B. I would use this formula. I would use that formula. So the 270 is acting like the A and the 60 is acting like the B. So when I'm using my formula, it is cos A, cos B. So I'm going to write cos 270 degrees. Just write cos 270, right? Then cos B, B is 60, right? Kirsten and Nicholas. When you're using the formula for cos, it have something to remember. Nicholas, you notice when it's a negative, it's positive in the middle.
Yeah,
Yeah, just be careful of that. So cos 210, that's 270 minus 60, which means I have to add sign in the middle. So cos 270, cos 60, plus sine A, A is 270, sine 270, B is 60, sine 60, right? So tell me, what is cos 270? Nicholas, what's cos 270?
that is plus 270 is 0.
Yeah.
Zero.
What's cos 60?
Uh-huh.
Right? Where's sine 270?
-1.
Right? Sine 270 minus 1. Right? And what is sine 60?
3/2.
Root 3 over 2 or 3 over 2?
3/2.
You mean root 3 over 2?
Yeah, 3/2.
I hear in 3 over 2. As in,
I don't know what's going on with this laptop. Um, like,
mm-hmm. Now this whole thing will just be 0 because 0 by anything is 0. And then we're going to get minus 1 by root 3 over 2, which is minus root 3 over 2. Awesome. Right? And that's how you handle a question. So, Kirsten, you could take this down real quick. In the meantime, Nicholas, I'm going to give you a question again. I want you to figure out what cause A. Actually, hmm. Hmm. That'll be too easy. Yeah, that'll be too easy. Wait. So, Kirsten, copy this down as fast as you could. And let me know when you have it down. Okay, that was fast. Nice. Nice. Right, so I'm gonna give Ollie some questions now. Yeah, I want you all to try these questions. Sine 225, sine 315, and cos 300. Give it a go. I'm giving you all 10 minutes. Right, Kirsten, I want to get pictures. I want to see that you're doing it. Yeah. All right, Nicholas, Christian, I'm moving on.
And the last question.
All right, Christian, moving on. Okay, on the second one, all right. All right, so Nicholas, what was the final answer for the first one? You have to write that. See how you write the final answer for two and three. You gotta write the final answer for one.
Oh, I am here.
So one and two are correct. I'm gonna check the last one. Yep, the last one is correct as well. Listen, I'll give you 3 more minutes again. 3 more minutes again. Well, it still have 2 minutes on the timer, so yeah, take some time. Yeah, we nearly finished. Nicholas, I have this meme going around on TikTok. It really reminded my chill guy me.
Yeah, I just a children.
Yeah. Can I show what Kristen wants? Let's message now. Right, and here and I'm seeing Kristen's already solutions on the board. I'll do up the solutions and she's checking the recording. Right, so Nicholas, let me speak through the solutions. What two angles could I add or subtract to get 225?
Could add 180 and 45.
And if I wanted to subtract, what could do? What two angles I could subtract?
Um, subtract.
Actually, I don't think that would work, I was thinking 270 and 45. But yeah, that would work. That would work, yeah.
Yeah.
45. No, wait.
Oh,
Yeah, it will work. Yeah, 225 would wait. Right, so 180 plus 45. So A is 180 and B is 45. So tell me what to write.
Um, writing sine, well, sine 180 cos 45 plus cos 180 sine 45
Right, continue.
that will be 0 plus minus root 2 on 2.
They're already full thing. Sine one. So sine 180 is 0 and cos 45 is root 2 on 2, right? And then we have plus minus. Well, tell me, what is cos 180?
Plus
How many?
180 is minus 1.
Hmm? And sine 45 is root 2 on 2. This whole thing here will be 0. This whole thing here will be minus root 2 on 2. Your answer is minus root 2 on 2. Right? Sine 315. What what two angles I could add or subtract to get 315?
I add 270 and 45.
You want to try minusing and see if it will work out?
Yeah. Minus 360 minus 40.
Right. Tell me.
So that would be sine 360 cos 45 minus cos 360 sine 45.
Yeah. Mm-hmm. What
Sine
is
360 is 0.
cos 45? We know that is root 2 over 2, right? And we know what's cos 360.
Cos 360 is 1.
Right, that's 1. And sine 45, we know sine 45 is root 2 on 2. And the answer is supposed to get is minus root 2 on 2, which we will get. So we're good to go with this, right?
Yeah.
Right, so that's one solution. Let's put the other one, right? Or you could have say sine we could have say you could have add
Sine 70
270, right? 270 plus 45. Right. Question 3. You could either add or you could minus. Wait, which one you want to go with? Addition or minus?
this one I minus.
All right. So they get 300. What you can say?
So cos 360 and cos 6.
You mean minus.
Yeah, minus cos 6.
Right. Or we could say, see if we could think of two angles you could add.
Um, 1/8 and 270 and 30.
Yep, as it. Yeah, man. So that's two ways you could do it. You could say cos 360 minus 60, or you could say cos 270 plus 30. Regardless, you'll get the same answer. Because maths is fly. Maths is cool. Right? Let me just do this fast. So that'll be cos A cos B minus sin A sin B. Right? So that'll be cos 360 cos 60. Right. One thing. Since we're minus in the angles, what sign do I have to put here?
Addition sign.
Right. So cos 360 cos 60 plus sine 360 sine 60. What is cos 360?
Plus 360 is 1.
Right, what is cos 60?
Plus 60 is a half.
With sine 360.
0.
And sine 60.
3 over 2.
Right, so my final answer is just a half. Is that correct?
Yeah.
Yeah. Nice. Kirsten, I understand you're having some Wi-Fi issues. Don't worry. You could always watch it back in your recording. You didn't miss anything. Uh, right. So Kirsten, all these solutions here. You could look back at any notes or the recordings. No beat up. The last trigonometric identity is tan A plus B and tan A minus B. This is I can't remember the last time I see this, right? An alternative, and this is what I recommend, since sine and cos so easy to remember, this is where you could also do. Nicholas, make a wild guess. How do you think we could write tan A plus B?
Tan A plus B.
Make a guess. If tan 2 theta was equal to sine 2 theta over cos 2 theta, if tan theta is sine theta over cos theta, see if we could figure out something. I think tan A plus B will be equal to. I think we could write that.
Um, Sine A over
No,
plus B.
not sine A,
Sine A plus B.
right? Yep, that's it. And tan. So I most likely only going to forget this in the exam, but you most likely wouldn't forget this. Sine and cos easy to remember. Plus, it just give you it in the exam. It just give you sine and cos. So it best to just work with sine and cos, honestly, right? Yeah. So you have to copy down that.
Adam.
Yeah, have it copied down.
Yeah.
Nice. All right. Now we're gonna move on to something. Okay, look at the proof here. Look at the proof here. You'll probably copy down the proof. Um, yeah, you all should probably copy down the proof. Yeah, copy down the proof. So that's the proof for why tan A plus B is tan A plus tan B all over 1 minus tan A tan B. That's the proof there. Nicholas, how you find out that proof looking? Hmm.
Looking
Hmm.
a little strange.
Yeah. You know they could ask this question. Like no joke, they could ask this. They could ask it. And you know what? People will get this wrong. An insane amount of people.
I think I'll be able to figure it out with because the numerator and the denominator, the identities is the same as just sine A plus B.
What do you mean?
The same questions we was just doing,
Yeah.
the would be sine A plus B and just substituting it is the same thing just as a fraction.
Hmm. More or less. The hard thing about this is knowing that I had to divide by cos A cos B on both sides. That's the tricky part. You remember in in the proof questions we did, you had to multiply on the top and bottom by something. Remember that?
Yeah,
Yeah, well in this question you had to divide by something on the top and bottom. These questions are the tricky ones. Let me show you how we could see it. So see you understand how to get to this part. Like this part real easy. This part
yeah,
over.
that, yeah,
Really.
that's stuff.
Now let me think. How are you gonna get tan A? How are you going to get tan A? How are you gonna get tan B? Oh, how are you gonna get tan A? Well, you gotta divide by. If I have sine A cos B and I wanna get tan A, and I would have to have cos A in the bottom.
Yeah,
And since I just want tan A, wouldn't I want to cancel off the B?
yeah,
That is why I divide by cos A cos B. Does that make sense?
yeah, yeah, it makes sense.
Another way you could see it. Another way. Look at this term over here. You want to get 1 on the bottom. What I have to divide cos A cos B by to get 1.
After divided by cos A cos B.
Right. Have to divide it by itself. So that is why we divide in the top and the bottom by cos A cos B. You can see it. It's not that hard to see. You can see it. It's there. It's like it's not a hard proof. In hindsight, it's not a hard proof. It's just it might give all some trouble to figure out that you had to divide on the top and bottom. That's the only trick I see. Okay, so you're talking about this question here, number 2. Okay, I could re-explain it after you all copy this down. When you have that copy down, I'll go over it one more time.
I have it copied.
All right, Kirsten, do you have it copied down? The proof for tan A plus B. Okay, cool. Let's go over question two one more time. Now we want to get 315 degrees. Now there are two ways you can get 315 degrees. Option one, you could minus 45 degrees from 360 degrees. So 360 minus 45. That's one way. The other way is to add 270 and 45. Kirsten, which way you would I see? The 360 minus the 45 or the 270 plus the 45? Okay, no problem, Nicholas. Tell me, Kirsten, how you would I see it? You would either add 270 and 45, or you would add minus 360 and 45. Both giving you 315 degrees. Minus. Okay. So tell me, what confusing you? Which part confusing you? Like, how I get this line? All right. Kirsten, to get 315 degrees, I said that I have to minus 360 and 45. So I have to use the compound angle formula that has minus in it. So I'm going to use the formula sine A minus B. And that formula, drop in the chat, what is sine A minus B equal to? What is sine A minus B equal to? Put in chat the formula. Kirsten, do you have the formula for sine A minus B copied down? Okay, I see something in the chat. Sine A cos B minus cos A sine B. Perfect. That's the formula, right? The formula is sine A cos B minus cos A sine B. So Kirsten, what is A and what is B? Drop in the chat. What is A and what is B? A is 360 and B is 45. That's correct. So now I'm just gonna substitute into the formula. So sine A is 360, so I'm gonna say sine 360. B is 45, so I'm gonna say cos 45. Again, I just follow any formula. Then cos 360 because A is 360, and then sine 45 because B is 45. You understand how I get this line? Yeah, yeah, that's just basically what I'm doing. So this A, this B, we're just plugging it in. And I'm doing that for all, right? Look at this one. A plus B, A is 180, B is 45. So sine A, sine 180, cos B, B is 45. Cos A is 180, B 45. Right? Since your Casio do give you the answer in the exact form, unfortunately you have to remember this, which is unfortunate. See if you can get a Casio. See if you can get a better Casio. I would really recommend getting the other Casio because it will make your life so much easier. Because you wouldn't have to remember any of that. Um, yeah, let me send you a Casio app. Okay, no problem. By chance, does it look like this? Okay, nice. I think that I sent it up. Yeah, okay, okay. That makes sense. If you use the app, it will work out. Like try putting cos 360. Put cos 360 and make sure it's in degrees. Someone Kirsten, when you put cos 360 and you get one, cos 360. Yeah, nice. So when you get the actual Casio, the Casio will do the same thing. Awesome. So I guess I understand this, right? Let me know if you're ready to move on. Right? Sure, no problem. I'm sending you a picture of the best Casio to get. I'll send it now. Wouldn't take long. That's the one to get. All right. Nicholas, are you back?
Yeah.
All right, cool. Double angle formula now. Let's go. So these are the double angle formulas. This is it for sine A, and this is for cos. It's for sine and cos. So they get sine 2A. And the reason why we call it double angle formula is because you're adding the same angle. So like double the angle. Like think of it, if you have 90 and 90, that's just double 90, which is 180, right? So the double angle formula is just sine 2A. And the other one is cos 2A. So for sine is 2 sine A cos A. For, for cos 2A is cos squared A minus sine squared A. Right? So you all could copy that down. Right, you'll have it copied out. Let me know which part you guys reached.
No, finish.
Okay. Right? Kirsten, let me know. All right, cool. Now we need to look at something. There are two different ways you could write cos 2A, the double angle formula for cos 2A. So cos A plus A is cos A minus sine A, which is just cos squared minus sine squared A. Do you all remember the main identity when doing trigs? What's the main identity other than tan theta is sine theta over cos theta? Yes, another main identity you need to know. It looks like this. Cos squared A. Somebody finish it. What's the main identity you need to know? Cos squared A.
Is cos square A minus sine square A.
Cos squared A plus,
Sine square A.
right, is equal to.
1.
Yeah, that's the main identity all you need to know. And we would have looked at it when we was doing trigonometric proofs. Right, so you need to know that identity. Need to. So if that is the case, from that, I could say that cos squared A is equal to what? If I make cos squared A the subject of the formula, what would that be equal to?
1 minus sine square A.
Right. Kirsten, if I make cos squared A the subject of the formula, I will move across the sine squared A. So cos squared A would now be 1 minus sine squared A. Right. And if I wanted to make sine squared A the subject of the formula, similarly, I would move across the cos squared A. So sine squared A, that would be equal to 1 minus cos squared A. And I'm going to apply that over here. So we know that cos 2A is equal to cos squared A minus sine squared A, but there are two ways you could write it. One, you could replace the cos squared A for 1 minus sine squared A, and if you do that and you simplify, you will end up with 1 minus 2 sine squared A. That's one way you could write cos 2A. Other thing you could do, you could replace the sine squared A for 1 minus cos squared A. And if you do that, you're going to end up with 2 cos squared A minus 1. Yeah, so you all could copy this down. Kirsten, if anything confusing you, let me know. I don't mind going into over. Alright, so as soon as you'll have this copy down, let me know. Nicholas, you understand this, right?
Yeah.
Cool. Kirsten, what about you? You ever see the identity before? Cos squared A plus sine squared A is equal to 1.
I'll finish.
Okay, nice. Kirsten, what about you? You finished? Okay, nice. So basically what I'm saying is because there's this identity, cos squared A plus sine squared A is equal to 1, and there are different ways you could write cos squared A and sine squared A. You can make a substitution and change depending on where you say cos squared A is or sine squared A is. That's why you have two different ways you could write cos 2a. Or you could play it safe and just write it like this and change it afterwards. Okay, so um oh, and this is something you should know as well. You should probably know this, right? So copy this down. Nicholas, you see what's remember the question I gave you to try at the start of class?
Yeah.
What tan 2a is sine 2a over cos 2a. Yeah. So you all could copy that down.
Yeah.
Okay, nice, nice. Kirsten, do you have this copy down? All right. Kirsten, let me see what you said. Okay, you have a copy down too. Nice. All right. All right, so let's just do this question here. Okay, so we looked at trigonometric proofs the last few classes. Now we're gonna in now we're gonna put in double angle formula into it. So let's go. Nicholas, question one. We're trying to prove that 1 over sine 2 theta minus 1 over tan 2 theta is equivalent to tan theta. First thing you do, you consider the left-hand side. So we have 1 over sine 2 theta minus 1 over sine 2 theta over cos 2 theta. Nicholas, why did I change the tan 2 theta to that?
Because tan 2 theta is equal to sine 2 theta.
Yes, and when we do in trigonometric proofs, you have to work in terms of sine and cos. Nice. Next thing. Nicholas, where's another way I could write 1 over sine 2 theta over cos 2 theta? Think of
Cos
fraction.
theta over sin theta.
Right. We could flip the fraction. Listen, let me know if you're okay with what we're doing so far. So I said that tan 2 theta was sine 2 theta over cos 2 theta, right? And then in this over here, I flipped it. What I did. All right. Now, Kirsten, do these two fractions have the same denominator? Do they have the same denominator? 1 over sine 2 theta minus cos 2 theta over sine 2 theta. Okay, cool, cool. So they have the same denominator. So what does that mean, Nicholas? If they have the same denominator, how could I write that?
You could find the LCM and you could add.
Right, so I'm gonna find, but you don't have to find the LCM, they have the same denominator. I'm gonna ask you a question. If you had a half, if you had a half plus a half, find the LCM, right? I just add it,
I just added.
right? If you had a half plus 3 over 2, and you just add that and say 4 over 2,
Yeah,
because they have the same denominator, and these two fractions have the same denominator.
yeah.
Yeah, they have sine 2 theta. So what am I gonna write?
Alright, so you're playing everything over sin theta. And for the numerator, yeah,
That's what it was gonna do.
yeah.
Nice.
I was gonna say sin square theta equals 1 minus cos.
So what we know cos 2 theta is now. Now we had to make the replacement. Now we have to we simplify it as much as we could here. Right now we have to make the replacement. So what is cos 2 theta? What do we know cos 2 theta is equal to?
Cos 2 theta is equal to 1 minus sin.
Let we take it. Let me go in baby steps. Cos 2 theta, isn't that cos square theta minus sine square theta?
Yeah.
Right. And what is sine 2 theta?
Sin 2 theta is sin 2 theta.
Double angle formulas. Sine 2a is the same thing as sine 2 theta. The same thing.
Yeah,
So
yeah.
what is sine 2 theta?
Alright, so sin 2 theta is 2 sin a cosine.
Right. So sine 2 theta is 2 sine theta cos theta, right? You okay?
Yeah,
All right. Now, we want to get tan theta, and as the objective, tan theta.
yeah.
Now, to get tan theta, what we know tan theta is.
Tan theta is equal to sin theta over cosine.
You see, not cos theta down here.
Yeah.
All right, so are we going to interfere with that? Do
I would leave.
we don't want to interfere with that, right? We don't want to interfere with that. We want to leave the cos theta there. And on top, so you have the cos theta, So on top, and wait, look at something. You see any sine theta in the bottom?
Yeah.
Talking about over here. You see any sine theta over
Oh,
here?
nah.
No. So we need to, whatever we do on top, it must work out so it's so like it cancel off with the sine theta in the bottom. So what would we need on top to cancel off with sine theta? What would
On
cancel
top,
off with sine theta?
sine theta.
Yes, sine theta. So we need to write this expression in terms of sine squared theta. Right. That's what we need to do. Let me just expand this first. So expand it from that'll be
Alright,
one.
so one, alright, so one by cos theta, cos square theta is just cos square theta.
Right. So one
And
minus
one,
theta.
one by minus sine square theta is just minus sine square.
Now what? Minus cos squared theta. Now minus by a minus.
Or positive
Very
sine
good.
square.
I want somebody to remind me. What is one minus cos squared theta equal to?
Sine square theta.
Right. I think all you can see the light at the end of the tunnel from here.
See it?
What is sine squared theta plus sine squared theta?
2 sine square theta.
Mm-hmm. Mm-hmm. You seen anything I could potentially cancel off?
Seeing that the sine square theta will cancel.
Come on again.
The 2 sine square theta will cancel.
Well, the two on the two will cancel off, and one of the sine theta in the bottom will cancel off with one on top. So what we're gonna end up with?
Sine theta over cos theta, which is equal to tan theta.
Bam. All right, sine theta over tan theta. We have sine theta over cos theta, which is equal to tan theta, right? And that's the proof there. That's it. So that's all you within. Yeah. So you all could copy that down. Listen, have any parts that confuse you? Like, just to drop it in chat. And then if I could go over anything. Not so far? Well, that's the end of the question. If you understand everything up to that point, then you're good. That's it. So the question wanted us to prove that the left-hand side was equal to tan theta. And we proved that. Proved that it was equal to tan theta. So Nicholas, I want you to walk me through the stages of this question. What we do?
Alright, so first of all,
First of all,
we change from tan 2 theta to sine 2 theta over cos 2 theta on the denominator.
and is it and do we do that just for this question or like all questions?
All question because it's gonna be in terms of sine and cos.
Right. What next?
After we change that, we're going to invert that fraction to put, well, to make, well, how it is 1 over sine 2 theta over cos 2 theta,
Mm-hmm.
inverting the denominator to make it just one normal fraction. So it'll
Right.
be cos 2 theta over sine 2 theta.
What next?
So that's that. Now from there, we see in the denominators is the same. So all we have to do is just subtract the numerators normally.
Mm-hmm.
But we're not actually subtracting. Again, we just using our identity.
Wait, what do you mean we not subtracting?
How these subtraction sign they, well, if it was a normal fraction with normal numbers, you would subtract. But these are identity.
Wait, which line are you talking about? this time.
About yeah, right.
But what do you mean? You was minusing these two fractions, so that's why we say 1 minus cos 2 theta.
Yeah,
Yeah, watch. 1 over sine. If imagine if I had 1 over 5 minus 3 over 5. How I gonna write that as a fraction?
1 minus 3/5.
Same thing here. Yeah. Right? What next?
Right. So cos 2 theta, the identity of cos 2 theta is cos square theta minus sin square theta.
What if you forget the brackets? What happen?
If you forget the brackets, a problem because you have to expand the bracket in the next part.
Yeah. Because this
And
whole thing, you gotta put it in brackets because the brackets mean that whole thing. So this whole thing, that whole thing stands for cos 2 theta. You gotta put it in brackets. That whole thing. Tell
yeah,
me.
right. So after you do that, the denominator will in one time. So sine 2 theta, that's also another identity. And
Yeah.
that identity is 2 sine theta, 2 sine theta plus theta. So the next part of the question from the brackets, just expanding on that. Again, 1 minus plus square theta plus sine square theta all over 2 sine theta plus theta.
Right.
And well, the most basic identity is 1 minus cos square theta is equal to sine square theta. So you're doing that one time. And well, sine square theta plus sine square theta is 2 sine square theta. Cancelling with the denominator, you're removing 1 from the power. So the sine theta over cos theta.
Yeah.
And sine theta over cos theta is tan theta.
That question wasn't that bad. Right. And I had another way you could do it. Watch. Let me show you the alternative. So when you reach this point, right? Let me show you something. So yeah, after you combine it, and we know that sine square theta plus cos square theta is 1, and we know that.
Yeah,
Yeah. I could replace the 1 for that. And when I expand brackets, the cos squared and the cos squared will cancel off. And that'll leave us with 2 sine square theta. That's another way you could do it. Yeah, it's another
yeah.
way. Let me do that. Hmm. Right, so you all don't have to copy down the O if you don't want to, but that's just another way you could do it to get the same answer. Right, so you all could copy this down.
Anna.
Okay, good job, Nicholas. Kristen, you can drop in the chat when you finish. Nicholas, this is it for trigonometry, you know. I'll give you this one question, but that's it for trigonometry. We did everything. Nice. Past paper time. So next class, we're gonna do past papers on trigonometry and look to move on to calculus. Right. So I want you all to try this question for me. Try that question.
Uh,
Yeah. Nicholas, any luck? You know how it going?
And slowly but surely,
All right. What was the first thing you do?
first thing I do is change tan theta to sin theta over cos theta.
Yeah, nice. Well, you shouldn't have any problems with this. I don't see you having any problems. You'll be good to go. All right, yeah. Give me updates.
I reach sin square theta minus cos square theta over sin theta plus
All right. You can do this.
here. I'm not too sure which part.
Where's that?
From day, I'm not too sure which part to go.
Apply yourself. See if you can figure it out. I know you can do it. A little tricky, but I'll give you 5 more minutes again. See if you can figure out something. Yeah. Any breakthroughs, Nicholas?
So, um, uh, from what just already the last thing, cancel out the squares and the denominator.
Okay. Did you see any light?
And sine theta minus cos theta.
Hmm. You want my help
That
there?
was, yeah,
It's like a S tier level question. I probably wouldn't go so far. Let me see. I may erase the solution here and come up with one. Right. First things first. We're going to replace theta and theta. So I'm gonna write sine theta over cos theta. Right? Minus one all over sine theta over cos theta. Right? And that would be equal to sine theta over cos theta minus what?
cos theta over sine theta.
We gotta do next.
From there, I put everything over sine theta cos theta.
See if I find the what?
Yes,
Right? So LCM is sine theta cos theta. Right? What next?
then on the numerator, add sine square theta minus cos square theta.
Right. This is where things get very tricky, right?
Yeah, these are get lost.
Hmm. Boy, oh boy. Let me think. Do we know do we know what sine square theta minus cos square theta is? Hmm.
I have minus 1.
No, it's a minus one. Which is
Um,
like one. One is equal to sine square theta plus cos square theta, right?
yeah,
Which would mean minus one would be equal to minus sine square theta minus cos square theta. Let me explain. Minus one wouldn't that be equal to minus open bracket sine square theta plus cos square theta?
yeah,
Because this whole thing is one.
yeah.
When you expand there again, minus sine square theta minus cos square theta. That is minus one. This is not minus one. This is not minus one. You know any identities as are kind of similar to this?
Um,
Double, give you a hint there. Double,
double side of function.
what is it?
Say double side of function.
Doubles?
Yeah, just now, what's this good? Uh, Sine square theta minus cos square theta, right?
Yeah. We're looking similar to which identity you know have a minus sign in the middle. So far, the ones we learned today in class, we look at cos A plus B, sin A plus B. We also look at sin 2A and cos 2A.
Sine 2a is cos squared theta minus sine square theta.
Wait, you're talking about sin 2A?
Cos 2a.
Where's cos 2A?
Cos 2a is cos squared a minus sine squared a.
So if I write that in terms of theta, that'll be cos 2
Cos,
theta. is equal to cos squared theta minus
Right.
sin squared theta, right? Let me try something now. Let we um let me try making it negative. So let me see what negative cos 2 theta is equal to. This is a tough question. You really had to see. Yeah, you really had to see the vision. Right? So minus cos 2 theta. That would mean I put in this in brackets. So that'll be minus cos squared theta minus sine squared theta. What I'll give you when you expand?
That would be sine squared theta minus cos squared.
Yeah, right. So what we're gonna replace it up with.
Minus cos 2 theta.
And now in the bottom we have sine theta. Right. Now, or is that working? Now, we're going to try to utilize another identity. That's what we're going to try to do. Utilize another identity. No. But I wonder how this will work out. Huh. Thinking. Let think. It's an interesting question. Hmm.
Denominator is with time now.
Wait a minute. Wait. I think I see in something. No. I'm going to try something. It's a tough question to make me think. Let me see. If I multiply the top and the bottom by 2, and the reason I'm doing that is because look at the bottom. The bottom is sine theta cos theta. What identity we know? What's the identity for sine 2 theta?
Sine 2 theta is um 2 sine A or 2 sine theta cos theta.
Right, but we only have sine theta cos theta. And
Yeah,
so let me try something. What if I multiply the top and the bottom by 2? I go end up with minus 2 cos 2 theta all over. I go end up with 2 sine theta cos theta. And what we know 2 sine theta cos theta is.
that is 2 sine 2 theta.
Whereas it's 2 sine theta cos theta.
Sine 2 theta.
Make a mistake in this. It's supposed to be tan 2 theta. Yeah. Right. So let me see what to do next. So we're trying to prove that that is equal to minus 2 over tan 2 theta. That's what we're trying to prove. So remind me, what is tan theta again? What is tan 2 theta? I could write,
Tan
how I could write tan 2 theta?
sine 2 theta over cos.
But instead, what we have,
We have minus 2 cos 2 theta over sine 2 theta.
forget about the minus 2. I could pull out that minus 2 if I wanted. I could pull out the minus 2 and write, I could write that. You know what I mean?
Yeah, so it's
So,
just cos 2 theta over sine 2 theta.
but what is that? If I know that tan 2 theta is sine 2 theta over cos 2 theta, then cos 2 theta over sine 2 theta is the opposite, right?
Yeah,
So tell me, where's the opposite of tan 2 theta?
minus sine 2 theta.
Nah, What's the
uh,
opposite of 1 over 5?
5/1,
Right. So what's the opposite of tan 2 theta?
1/tan2 theta.
Yes. Because if I flip the both sides, I would end up with 1 over tan 2 theta would be equal to cos 2 theta over sine 2 theta. Is that correct?
Yeah,
Yeah. A tough question, definitely. Definitely a tough question. So I'm gonna write it as minus 2 multiply by cos 2 theta over sine 2 theta. And what we know cos 2 theta, sine 2 theta is again?
tan 2 theta.
Not just tan 2 theta, 1 over tan 2
1
theta.
over tan. And then the minus 2 multiplied by the numerator.
Right. And you get your answer. Definitely a tough question. Probably the hardest question I'll ever see on this. Yeah, so you'll copy this down. Definitely a brain scratcher. Right, so after you all copy down this, I'll wait for class today. Where we end off, it's a tough question.
Real tough.
But I realized I make a mistake because I had 2 over tan theta, which is impossible. Really supposed to be 2 over tan 2 theta. That was my bad. Even if it was going good, I think you're going wrong because you're not seeing what you're supposed to get. So I put,
Yeah, but I feel I will still get time up there.
hmm.
Ah,
All right. Kirsten, what about you? I mean, if you have that copy down. Kirsten, you have that copy down? Let me know. Okay. All right. Well, thank you so much for coming to class today, guys. Nicholas, you sound like you're feeling better. A lot better. Just good.
yeah,
Nice. Well, yeah, that's it for trigonometry. That's it. We done. Nice. Um,
long list of
let me just review everything we do one more time. So we looked at radians. We do questions with that, like circle or sector. We did area of sector, length of arc, those kind of questions. We looked at the we looked at finding area of a triangle with an included angle. That was a half AB sine C. Then we look at sketching graphs. So like sine, cos, and tan. We also did finding Remember the quadrants? We had to find all the
Yeah.
solutions. We also did that. We did it for 360 and beyond 360. We did trigonometric proofs and we did trigonometric identities. We also did questions involving unit circles. Yeah, we basically did everything on the syllabus. Well, not basically, we did. The next class, past paper questions and calculus. We're going to move on to differentiation and integration.
Oh,
Right. And after that, we not finished with the syllabus. We still had to do statistics and probability and kinematics. Yeah, that'll be it.
yeah.
You're not gonna like statistics and probability.
Tough feeling.
Yeah. Uh, differentiation and integration, not so bad. I don't think it bad. I think it's one of the easier things. Uh statistics though, it's so boring. You have to draw diagrams and things sometimes.
Diagrams and art maths.
Yeah, let me show you. Box and whisker and thing. You know what's a box and whisker diagram?
Oh, yeah, yeah, yeah. Do that maths.
No, you would not do box and whisker in maths. At least I don't think so. Talking about like this.
Yeah, how many quarters and thing.
Well, you do this in maths?
I can't remember if it was maths or art maths, but I know it was in Form 3. Miss Priya was my teacher for maths and art maths.
Okay. And you had to remember formulas. Well, that's not a hard formula to remember. But I don't know, maybe I was overlooking. Oh, look at this. Look at this. What's that?
Only thing I know is the first one.
Well, it have a easier formula to use. This formula. You can use this formula and get your answer immediately. Or you could do this. You don't even have enough you don't even have enough space for that.
Not looking like pressure.
Right? But yeah, thanks for coming to class today, guys. I'll see some all day Monday, some all day Friday, and back Saturday. Later, guys.
Yeah, later.
Have a good day.